Welcome back. In this tutorial, we'll be looking at the AP Physics 2 homework assignment, Net Electric Force in One Dimension. In this particular assignment, there are three problems that we will do. Question 1, find the electric force between two charges. Question 2, find the electric force between three charges. And then finally, question 3, force electric in a line, where we will find the net force acting on one charge. Let's begin. So for question 1, we're going to open up the link to the program, force electric between two charges. Okay, now in this particular one, your job is to find the distance between the particles as well as the magnitude and direction of the force on the particles. Let's begin. Now, the first thing I'm going to do is I'm going to label the two charges and their locations on my paper. Okay, now it says the focus is on charge 2. We have to find the distance between the charges as well as the magnitude and direction of the force experienced by charge 2. In other words, what is charge 1 doing to charge 2? Pushing it to the right or pulling it to the left. All right, so we'll get to that in a minute. First, let's copy down our information. Now, keep in mind, when you put in your name in your program, you're going to get different information. So use my tutorial as a template for how to solve your problem. Don't simply copy my work, otherwise you won't get the problem right. So my charge 1 is 219 nanocoulombs, and it's at 9 millimeters. So Q1 is a positive 219 nanocoulombs. Charge 2 is on 43, and that's negative 400. Okay, now if we subtract the positions, right, 43 minus 9 would give us a distance of 34 millimeters. Now, for the program, we can enter millimeters in here just fine. 34 will be just fine. But in order to make the force calculation happen, we're going to have to sorry, let me fix this real quick. In order to make the electric force calculation happen, you're going to have to convert the distance from millimeters to meters. So don't forget to do that, okay? Move the decimal 3 to the left, and our distance between the two charges is 0.034 meters. Okay, show the direction of the force on the charge. Well, Q1 is positive, Q2 is negative. That means Q1 is going to pull Q2. So if this is Q2, Q1 is going to pull Q2 to the left. And the force on it would be the force of 1 pulling on charge 2. Now for step 3, let's actually calculate F12. It's going to be K Q1 Q2 over R squared. And we're going to go 9 times 10 to the 9 is our value for K. My first charge is 219 nano times 10 to the negative 9 times 400. Remember, we don't put the negative in the equation. It's the absolute value of the charges. So 400 times 10 to the negative 9 all over 0.034 squared. Okay, let's run this calculation. I'm going to go open parentheses, 9 times 10 to the 9 times 219 times 10 to the negative 9 times 400 times 10 to the negative 9. Close those parentheses, divide, open parentheses. The distance between was 0.034. So 0.034 parentheses squared. And I'm getting a value of about 0.682. To the left. Let me put that information in the program and let's see how we did. This up here to the left. There we go. And there we go. You can see that I was able to get question number 1 right. Hopefully you were able to get question number 1 right as well. Let's move on to question number 2. And yes, we're not doing step 4. In question 2, we now have 3 charges. Okay, first we're going to label them. In step 2, we're going to find the force of charge 1 acting on charge 2. In step 3, we're going to find the force of charge 1 acting on charge 3. And then finally, step 4, we're going to find the force of charge 2 acting on charge 3. So we're just going to basically calculate the electric force between 2 different charges 3 times. First, let's label. Open up your program and let's begin. So my Q1 is 442 at 14. (442) nanocoulombs. And my Q2 is 251 at 24. And my Q3 is 331 at 32. 331 nanocoulombs. Okay, so let's kind of map out some distance here. The distance between 1 and 2, okay, would be what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 millimeters, which you will convert to meters later on. The distance between 1 and 3, 10, 11, 12, 13, 14, 15, 16, 17, 18 millimeters. And the distance between 2 and 3, 1, 2, 3, 4, 5, 6, 7, 8, 8 millimeters. Okay. So let's find the force between 1 and 2. Now, since all of these are positive charges, they will all push their other charge away. So for instance, these would be repelling. So let's find the magnitude of the force F12. So K Q1, Q2 over R squared. We're going to go 9 times 10 to the 9 times, now charge 1 is 442 times 10 to the negative 9, and Q2 is 251 times 10 to the negative 9, all divided by, now 10 millimeters would be 0.010 or 0.01 squared. Okay, so let's find F12. Okay, so 442 and 251. Times 10 to the 9. Oops, back that up. Open parentheses, 9 times 10 to the 9 times, I already forgot, 442 and 251. Okay, 442, 42 times 10 to the negative 9 times 251 times 10 to the negative 9. Close parentheses, divide, open parentheses. The distance between them was 10 millimeters or 0.01 squared. Okay, and I'm getting about 9.98. And yes, it's repel. F13, same thing, but it's going to be KQ1, Q3 over R squared, specifically between R1 and 3. So we'll go 9 times 10 to the 9 times Q1, 442, times Q3, 331. Okay, divide that by the distance between 1 and 3 is 18 millimeters, which is 0.018 meters quantity squared. Since they are both positive charges, they will be repelling as well. But let's figure out what the magnitude of the force is. Open parentheses, 9E9 times 442 E negative 9 times 331 E negative 9. Close parentheses, divide, open parentheses. The distance between them is 18 millimeters or 0.018 quantity squared. And I'm getting about 4.06. Okay, and the last one we're finding is F23. So F23 is going to be KQ2 Q3 over R squared. So we're going 9 times 10 to the 9 times Q2. Q2 is, what's Q2? 251. Times Q3, which is 331. And the distance between 2 and 3 is 8 millimeters, which would be 0.008 quantity squared. Again, two positive charges will repel each other. But let's figure out the magnitude of the force. So 251 and 331. We will go open parentheses 9E9 times 251 times 10 to the negative 9 times 331. Do have those correct, don't I? Yes. 331 times 10 to the negative 9, close parentheses, divide, open parentheses, 0.008 quantity squared. And I'm getting about 11.68. Okay, and then step 5, of course, is just to enter these in the program and see how we did. And there you go. I was able to get them right. Hopefully you were able to get them right as well. Finally, on to question number 3. go ahead and enter your name and go ahead and take the time to copy down your 3 charges and their 3 locations, and I will copy down mine. Our job, by the way, is to find the net force, the total force acting on charge 2 from charge 1 and charge 3. In other words, charge 1 and charge 3 will be forcing charge 2 to move somewhere. So let's see. Go ahead and copy down yours. I'll copy down mine. There's Q1. That's negative 600. 23. That's 288. 288. And, oops, 37, and that's negative 267. Okay, so I've got 2 negative charges and a positive charge. So the first thing we're going to do is we are going to figure out, in step 2, we're going to show the calculation for the force between the 2 charges, and we're going to make sure we indicate which 2 charges you're working on to be able to do this, okay? So the first thing I'm going to do is I'm going to draw the force of interaction on charge 2. So draw a dot down here to represent charge 2. Now, what is charge 1 going to do to charge 2? Well, notice charge 1 is negative, charge 2 is positive. That means charge 1 is going to pull charge 2 to the left because they attract. And I would label this F12 because it's the force of charge 1 pulling charge 2. Well, charge 3 is negative and charge 2 is positive. That means charge 3 will also be pulling, but to its side, to the right. And I would label that F32. Since your force vectors are going in opposite directions, you'll be subtracting them. You subtract the bigger force minus the smaller force. So I'm going to wait to see which one we subtract based on the magnitude of these 2 forces rather. So that's what we're going to calculate. We'll calculate F12, which is KQ1, Q2 over R squared. And then here we'll calculate F32, which is KQ3, Q2 over R squared. Go ahead and take the time to enter into our Coulomb's law equation while I go ahead and do mine. Okay, so I'm comparing 600 and 288. And the distance between them is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 millimeters is 0.015 meters. So F12 and would be to the left is the direction. Okay, let's figure out how much force is pointing to the left. Open parentheses, 9E9 times 600 E negative 9 times 288. 288 times 10 to the negative 9, close parentheses, divide open parentheses. The distance was 15, so 0.015. 0.015 quantity squared, right? And I'm getting 6.912. 6.912. Okay, now we're going to find F23 the same way. So 9 times 10 to the 9. Q3, way over to the right, is negative 267. Remember, I don't put the negative in the equation. So just 267 times 10 to the negative 9 times Q2, which is again 288. times 10 to the negative 9. Now the distance between 2 and 3 would be 1, 2, 3, 4, 5, 6, 2, 3, 4, 5, 6, 7, 8, 11, 12, 13, 14, which would be 0.014 quantity squared. This one is going to be to the right because you can see charge 3 will pull charge 2 to the right. Okay. All right. Open parentheses, 9E9 times 267. I think it's 267. Yeah. E negative 9 times, I believe it's 288. Yep. 288 times 10 to the negative 9. Close parentheses, divide, open parentheses. Distance was 14, so 0.014. Quantity squared, we're getting 3.53. 3. Okay, now since F12 is bigger, the net force is F32 minus F12. Sorry, other way around. Bigger force is F12 minus F32. So it's going to be 6.912 minus 3.53. And since it's directed in the direction of F12, the direction of the net force will be to the left. So go ahead and subtract those. Subtract yours. I'll subtract mine. 912 minus 3.3. So I'm getting about 3.38 newtons to the left. Well, let me see what all I had to put in the program. I had to put in the net force and its direction. So the net force is 3.38, my example. 3.38, and the direction was to the left. All right, there you go. I was able to get this one as right as well. So hopefully you were able to get your 3 questions for net force, net electric force, and one-dimension homework assignment, all 3 correct. Hopefully you found this video tutorial to be helpful so that you could do your problems with confidence. All right, see you next time.